this, but yeah, need not to follow exactly. So let's try to do some. They are calling them as a matrix plot, but actually this is known as correlation plots, heat map or cluster maps. Correlation in the sense, it actually tells you like how two of the category or two of the data set. Just now we actually wanted to figure it out in these plots how this data is actually correlated, this petal length or petal width or sepal width are related to each other. The same correlation we want to check on higher level. Actually, we will not go into deeper. So these are very frequently used, very easily we go for that. Actually, only you have to remember is like how these plots wo- are plotted, and second thing is what they signifies. So uh, correlation plots nothing but heat map. Yeah. We'll close this. So let's work on this flight's data, and it will make sense also. It's easy to understand. Let's see. So we will again import Seaborn. So as SNS, as yeah, there are some other people they actually import this Seaborn as SP. So don't get confused. Like yeah, they are doing SP, and so you can actually check what this data is. So if you remember, these are actually monthly basis passenger data for each of the, I think till 49 till 60s. So you can check how many years we have here. Like yeah. So you remember these commands. Yeah, unique will tell like yeah, I have some 11-year data they have, and these are monthly basis. So you can say 11 into 12, right? So these many data we have. 11 into 12, how many rows?
1 to 2, 11 into 2.
I think 12, one we are missing 149. So 12 into 12, 144 rows here. Right, 149 was also there. So 12-year data we have, 12 months, 144 rows, and each day we have this. So let's see how the correlation will. Okay, they actually, yeah. So tips. Oh, okay, we can directly call. So yeah, they are actually working. We can actually look. This is flights data. I think flight data will not make sense. Flight dot. You can directly call this core. This will actually give you numbers. And because year versus year, there will be no correlation. So exactly, it's not no correlation, 100% correlation because as a year increases, your year will increase, right? Correlation. Uh, when we say, let me explain on this paint also. Like, suppose two data set you have x axis and y axis. When correlation is one, right? It means it's crossing like this. So it means this axis is one. So if you increase x by some amount, delta amount, your y will also change by same amount actually. That is means correlation is equals to 1. They are equally correlated. When we say zero correlated, meaning even x changes, y will not change. And when it says negative correlated, meaning x is changing by 1 unit, so y will be decreasing by 1 unit. That is like y is equals correlation is equals to -1. So I think if you go for this one, actually plus one correlation, this graph is actually correlation equals to 0, and one axis is like correlation minus 1. And this is, you can say, x-axis, and this one was y-axis. So when the data is like correlated one, meaning if you increase by one value, it will also x value or y value will also increase by same value. But what will happen? Your correlation will always be between -1 to 1, and so this is the idea. Like these graphs or these core functions, we just call, right, CORR. So these are very much optimized, and they are actually giving quickly these values. Otherwise, you have to calculate manually. And after getting this value, actually, we by just now we told, right, yesterday also, like looking at number, you cannot figure it out anything actually. So it's better to visualize. That is why these visualization tools are helpful. And you, what you do, you call heat map, and then you pass the data, and nothing what you want to do visualizes nothing. It's a correlation plot of the same data. So when you call this, it will try to plot for you, and you can check why it is actually saying light color, because around 97 to 98%, 92% it is correlated, right? So okay, yeah, these are 92% is related by this uh, darker colors, and one is at higher color. And same again, you can change the color and what not patterns, and you can cmap is the, I think, command to give different types of color and all. Yeah, we can go in detail like what type of colors we want. I think this also data will not give any much information for this plot, this data set. Maybe we can check later. So one more, yes.
It's like how we are telling there is no correlation for the year the passenger will be related, right? In a year, how many passengers would have traveled?
Correct. This number is saying as year increases, our passengers are increases or not. This is the correlation it tries to find. Or as passenger increases, year increases or not. That doesn't make sense. So it's better to say like year, as year progresses, is passengers are increasing? Yes, they are 92% increasing. You can also check that from the data, maybe saying flights, and check the passengers. If you check group by on
Year.
year, yes, and aggregate sum, then actually you can check how these numbers are increasing. Yes, year by year, the passengers are around. See, this number is how much we can check, calculate, but it will not exactly that. This increased by how much? Uh, Wait, 1676 minus 1520 divided by 1520. It is saying, yeah, 90% they are correlated, but it is not saying how much percentage. So 10% it is increasing, kind of, you can say, every year. Oh, okay. What is the so When it comes like 10 percentage or increase in as year increases, your passenger count is increases. That is means they are positively correlated. And how the I think there is one more statistics will come exactly how this 90% is coming, and I think yeah tell you later maybe yeah what is the formula. So correlation.
Rishi, can we go to that later? I mean, that map place, two shades.
Mm-hmm. I couldn't get you.
I mean, can you scroll your cursor still down?
Yeah, this one.
Yes. Here it is giving like passenger to here to passenger. What is this black? I mean, this represents. Is it like is it related or not
No,
related?
no, this is representing this value 0.92, black one, and one is represented by light color. So these are like one.
No, no. Meaning of that is like is it related or is it not related with that data? So that I'm not able to understand.
Yeah, so when we say it is related or not related, you actually conclude from this data. When it is positive, when it is not related, it is zero actually. It will come zero, that value. And with when it is positive, they are related actually. So as year increases, your passenger will increase, or other way around, your passenger increases as your year increases. That is positive when it is positive number. Otherwise, it will come negative when they are negatively correlated, and when they are not related, it should come zero value correlation. So currently it is highly correlated. You can say 92% they are correlated, year and passenger. As your year increases, your passenger count will increase. That is the idea. Same that we can do for this SNS get data set. Wait, load data set, right? What is that syntax? Load data set. Or yeah, again we can do the same plots for tips data, and we can figure it out how tips are working. So the command is sns.heatmap and tips.core, and correlation will again give you. In this one, you can see they are saying zero point 0.5, so still they are positively correlated. Uh, some of the data set will have negative correlation, then you will find minus numbers, and then you can say or zero is there, then they are not correlated at all. And here actually one is represented by light color, right? So always the diagonal will be like light colors, and these colors actually the 0.71 or orange color, if it appeared, then you could have seen like yeah they are highly correlated. Now you can say only they are correlated, they are not highly correlated or just correlated. They are meaning tip and size, you can say they are correlated, but in comparison to tip and total bill and size, they are more correlated actually. I think there is another command where we can actually plot the numbers, right? Yeah, annotation is equals to true, and then actually you can see the values also on top of it. So yeah, these values are saying this much percentage they are correlated actually. Yeah, this value correlation value is this much, not percentage. Yeah. Any more doubt? Oh.
Basically, this correlation is like until what level they match or let's
Yeah, they match actually, you can say. When we say positive correlated, it means like your data is changing in the same direction if you are changing the other data. So it is meaning suppose your size is wait a second, total bill versus size. Let's see. This value is zero point 0.6, right? It is saying that 60% chance is that if your total bill size increase, your total bill will increase actually. This is chance also. It is not exactly, but this is 60% likelihood or probability that it is going to change. The total, if size increases, 60% probability is there that total bill will also increase. So size in the sense here, the if you remember, the size is
Number of
nothing
the
but
persons.
number of persons, right? And it is very, yeah, correct also. Like if four people are coming, obviously the bill
Hmm.
count, total bill will increase. If the two-person are coming, you can see two is 18 actually, or $17. But for some of the people, two is actually 23. So there is no significant difference also. So, but it depends also many factors. That is what you want to figure it out from the data. But on average, you can actually find same thing you can do for this tips data. Do the group by on size and figure it out. Is it really changing or not? But in this case, take the mean. Otherwise, I think it will not. Yeah, make some sense. Mean this will work. Yeah. So you can see for size 1, the mean total bills is 7, but for 4, it is 28. Actually, 4 times. And for 2 people, 16. But 3 and 4 is quite same around. But this is the general trend. It is 60% likelihood. Like as size increases, your bill amount is actually increasing. That is the idea it is saying. So if it is 1, it means by one value it will double actually the data. But exactly not it is the case, or highly it is not correlated. That is why it is not coming one value.
Okay.
Ah, yeah. So these are the two things. And similarly, I think this C map is the change of formatting you can do with the command passing this argument. You will actually change the C this heat map color, and what exactly we do is like it should be other way around. I think better find some warm color, only warm or cool. Uh,
Rishi, I have some work. I'll be
ಇಲ್ಲ
leaving
ಇಲ್ಲ ಇಲ್ಲ
today.
ಇಲ್ಲ, ನೀನ್ ಕಂಟಿನ್ಯೂ ಮಾಡು. ಅವ್ರು ಬಂದಾಗ ನಿನ್ ಕ್ಲಾಸ್ ಇದು ಮಾಡು.
Rishi, can I give?
okay, yeah, no issue. Yeah, yeah. So yeah, that is the idea. But actually, how we do this plot? Yeah, this is what this data actually they transform, then pivot the data, and then it will make sense actually while doing this such plots. We wanted to this. Okay, what it does, we did the pivoting over the year as a column and the month as an index and passenger values inside it. Right. Now, when you plot this one, let's yes. Now this one actually tells you, oh, yeah, this is actually heat map of count actually, right? This values
In
six
1949, how many passengers were there? For that, it is making a color shade.
color shade, correct. The entire data is colored format. Now actually you can see, oh, actually the years are actually splitted, or Jan, Feb, March is in the correct order and the years are in. So you can see as year increases, your this count is increases, right? As the lighter is the color, the counts are higher. And you can see the trend is highest in this actually June, July and August. and July has the highest number of passenger actually in entire data
It
set.
look like August is having highest. Like
Correct, correct. August or July, both are kind of similar, but yeah, around they are getting the highest number of the
passengers that month.
correct, yeah, higher number of passengers. So this heat map you can not only do on correlation, you can do on entire data set also, and you can this is actually tells you entire picture of data like how they are spread across the meaning it's a visual representation of your data set actually. On the Jan, you can say Jan 14, this 1949, very less number of people were there, but as increases, around 400 people were in the 1960s Jan. You can somehow you can say it by the
Okay.
numbers. So yeah,
And
so
who
it
will
is
define this
clearly
current
saying
state?
like in a year, uh, your trend is passengers are keep from Jan to July it will increase, and from July onward it will try to little bit decrease, but in the December there is some certain hike is there. So November are dull period and Feb are very dull period in my opinion. So Jan is highest, December is highest, little higher than the other 2 months, but typically highest is June and July, July and August actually. You can conclude on this data.
Okay. And
Yeah,
who will define this scaling regime? Like,
scaling is
here?
nothing but the numbers, right?
No, no,
This
no.
is
Here, like for 600, this is the. Can you go to the diagram? Yeah, yeah.
600 is the lighter one,
The
right?
lighter version, I mean, little lighter, darker. So it's like, I mean, as a fresher or beginner to see this, I'm getting like how to analyze based on the colors.
Actually, yeah, it should be in other way around. That is why I try to figure it out with this C map equals to cool or warm. So what we do is like higher, lighter should be lighter color and darker should be higher value, right?
Okay, this is like a constant value. If it is lighter, then that is having the most valued. If it is darker, it is having the least,
Uh,
like
yeah,
that.
yeah, correct, correct. So I
Okay.
think it will, I am putting in the wrong place. That C map should be here. When I put here, I think it depends. Or you can accustom to this value. Then you have don't no have challenges. Yeah, CMAP has no warm actually. Yeah, so some good one you can figure it out from here. Like this one. Let's try. Many are there that CMAP. So this will change the coloring. Whatever color you figure it out better, just put it. It is based on your convenience. It just giving the shades based on the numbers, right? So just now we wrote CMAP is equals to some garbage, then it will tell the what is the correct ones. Yeah, you can figure it out which makes you better one, I think. I also generally figure it out, yeah, which one is good. Yeah, just put it. Yeah, this is better, right? So you can say darker are higher, mid one is lighter are mid one, and the blue ones or blacker version are the highest one, lowest one, sorry. Yeah,
Okay, okay. It
this
is like,
depends on you actually. Yeah, I think there will be this also twilight. Yeah, this makes more sense.
huh.
No, not much. I think there is some blue. No, I think yeah,
There
this
was
is
something.
actually yeah. These are like format or yeah different colors.
Yeah.
Mapping is there. They already defined, predefined. Better to use them only. Yeah. Otherwise, yeah, this something like this will make more sense actually. Red ones are lighter in colors and mid in the numbers, and the blue ones are lowest in the numbers. Dark ones are very lowest, and lightest one are the highest in the numbers. So you can see some pattern is there, right?
Yeah. This is okay.
So this you can actually figure it out, which makes sense to you, or better to explain to people whom you are explaining. Then you can decide. Yeah. So by default, the color it comes was that one. So generally, people will also not use such colors. They will go with this, and you can say darkers are lighter, lesser values, and lighters are higher values. Yeah, this is one way. And similarly, I think yeah, this one more is there. I think line width is also you can pass more argument, and magma is the one more better version. I think
Color
you
format.
can yeah color format. Color mapping actually this is C map and light with let's see I think how this is I think these lines
Box it is divided
yeah
in.
correct box are divided it's just visual representation how you want to visualize your charts that is how this comes it's only numbers if you put let's say we put 3 how it works yeah it will make the box these
Mhm.
lines are bigger boxes nothing else and I think color will I think you can pass blue or something like this. Yeah. So it depends how you want to visualize your color data. No point, right? Passing these arguments. It's better to
Okay,
pass white.
this is
Yeah.
basic.
Yeah.
If finalization is done, then uh,
Yeah.
let me
Customization of the figure you can do whatever
in.
you need. Yeah. You want to put the numbers, then the annotation word was there, right? And note
Yeah.
yeah equals to true then I think it will put the numbers for you. Yeah, and why this will, yeah, then again, this is coming in 10 to the power something. No point of putting this. Yeah, is writing in different format actually. Yeah,
Can we do increase or decrease of this diagram? I mean graph.
yeah, definitely there will be that. You remember, right? We were actually saving this x is equals to this, and then ex dot fixed size. I remember, or maybe I need to check. Some 12 comma 12 suppose let's see yeah uh,
Like,
yeah that figure comma this and then figure probably yeah need to check is it some possibility will be there yeah obviously it's on the top of matplotlib right so again matplotlib functions will come to increase the sizes of this actually so I can check maybe increase. Yeah, so how I just checked, they are saying, yeah, you import the matplotlib and dot pyplot as plt and yeah, this one. Why they are using subplot? I'm not sure. Yeah, hopefully this should work or yeah, this is working. But I think yeah, this one we need to remove. Yeah. So you can increase like this. Yeah.
okay, Rishi. Actually, this is better for visualization, at least for beginners.
Yeah, correct. You as data increases, it what it tries to, like, you can see this one was bigger, and
Yeah.
this, yeah, this one was biggest, but later on it tries to, yeah, make it a small and make it fit to this shell actually, yeah, this cell. Similarly, the cluster map, actually, this is hierarchical clustering to produce the cluster version of this. And what it does is one more feature it tries to bring into is how they are clustered actually. So you can say this entire data, it is saying that you can divide into two subcategory, and within that two categories these are two are there, and then again they are categorized into two, and then again two are categorized, something like this. So it is saying it the yearly wise, you can say this uh, first 50 till 52 year they are into one category, 59 onward they are in other categories. Oh, actually, not the case. It just jumbled up who are in one cluster and another are in other cluster actually. So still you can figure it out saying like, yeah, more than lesser than 54 is in one category, and greater than 55 or 55 onward are in one category. So it just divided the entire data into two different category based on year also and based on the months also. So then again you can see this one saying Jan, Feb, November, March, December, May, and April. The October in one category cluster, you can say it is clustering into one format based on numbers. Actually, these are some maths going on behind, but you actually doing the hierarchical clustering thing. This also comes into in one of the clustering classes, or you can say clustering is another concept where you want to cluster two of the data, meaning finding some pattern between data and trying to, or to say trying to cluster them together, having some similar characteristics. But yeah, what we were plotting this one, right? PV plots, PV flights, yeah, pivots of the flight. So it's good to have such plots also. You can see September, June, July, and August are were actually in the highest of the number, right? The passenger counts were highest. So it clustered into one of the different cluster, and others 8 months into different cluster. And inside that, if you remember, Jan, Feb, and November were lowest, not lowest, yeah, in between the number of passenger, but December, March were in the one of the passenger. But remember, the June and September were closer numbers of passenger, but July and August was highly correlated, actually, kind of. So these are actually visually doing some meaning doing the clustering hierarchy and then visualizing it here in Seaborn actually. Yeah. So these are the two plots I think this had. Same you can, I think, standard scale. Okay, more options and cleaner version is there. Yeah, you can normalize this and figure it out better. Oh, okay, standard scale you can say, and then it will be based on 1%. So lighter colors are zero, and one is like highest values or highly correlated kind of higher data actually, not correlation.
For this
No,
clustering, we will be having a separate class, right?
yeah, class we can have. We can talk more on the clustering. Yeah, that is the thing. Okay, let's check what this grid one has. I think, yeah, they are pair plots and all we talked about grid. And yeah, this. Let's check this one. I also never plotted such graphs. Mm-hmm. Pair grid. Oh, okay. It's a pairwise relationship trying to plot, but when you just write this pair grid, I think just created the grid, nothing else. What to plot, it will decide later. So you can say map uh, plt dot scatter. So it will try to plot the scatter plot for each of the this combination. So pair grid was done uh, did just now. Let's try. Let's do it also side by side. SNS dot pair grid. Mm-hmm. Ah, what we missed. Oh, oh, we did the similar. Yeah. Okay. They actually did the pairing of the grid gen, but write some g is equal to this and g dot map is there. Plt dot scatter. So what it is doing is first it was created the grid. Grid was nothing but the combination total bill versus tips, total bill versus size, all the combination plotted. And later on, when you did this plt dot scatter, it tried to map all the data into scatter format, and you can see obviously scatter will be always like this, meaning as size was 2, your value of other size was 2 only, so it will be having same values. But for these one tips and total bill, it will be different, so you can figure it out some pattern out of it. And these are actually sizes were not the unique, you can say they are actually mm, how to say, yeah, discretized numbers. So that's why you are getting for 4 many points, 3 are many point, 2 are many point, 1, 5 and 6 are very less numbers. So these are like only plots on the grid. Similarly, I think, yeah, you can do scatter plot. Maybe you can do this KDE plot or histogram plot. Okay, yeah, this is like defining diagonally. I need histogram plot. So diagonally, it is doing histogram plot. And when you are plotting for upper half, it is plotting scatter plot on the upper half. And the bottom half you can define as a map lower with KDE plot. KDE is nothing the density plot. Actually, it's only saying how the spread of the data, but you can actually make some relation between this because this is same data actually, right? Sepal width versus sepal length and sepal length versus sepal width. You can see both are same actually, but only thing is axis got changed. This one with sepal length on the y-axis, sepal width on the y-axis, but here sepal width is on the x-axis. That's all. So I don't know, we can draw here or not. If you closely look, this is actually same as this one, and this one is actually same as this one. Can you see my cursor?
Yes, Rishi, but I also want the down one. Here, sepal width is there. Down, is it a sepal length on the
Yeah, yeah,
cursor?
correct, correct. Sepal length. So this sepal length versus sepal length and sepal width versus sepal width. So that's why you will get the this one. Can we crop somewhere? Maybe. No, I'm saying. So what I'm saying is this one is. Yeah, this one is sepal length, and this one is sepal width. And what I am trying to say is like, if you check closely, like this circle is nothing but represented by this one, and this bigger cluster is actually represented by this. Only the thing is, this is on the y-axis, now it is in on the x-axis, and this one was on the y-axis, now it is on x-axis, y-axis. Oh, here spelling is mistake. Yeah, correct. So it got just changed. Here it is here, and this one is here actually.
Okay, access changes are there. So that is
Yeah,
why
yeah, correct. That is
these.
why your figures will little change, but actually they are same data points. If you convert this into here, actually scatter, and this one will be kitty, then you can see both are same actually. And if you put both as a scatter or both as kitty, then you can figure it out actually. Yeah.
Okay. And do we have any comment to convert the graph? Like we have a histogram graph. Now we want that into a scatter. Like any convert dot convert kind.
No, you cannot, I think, convert directly. You can, what you can say is like, suppose you do this PLT, iris is not defined. So, yeah. Now actually you can see both are same. Only thing is this piece is here and this piece is here. But yeah, in this, I'm not sure. Yeah, we can put that hue equals to different one was not present here, right? I think. Yeah, maybe. Oh, okay. Yeah, we may need later. Yeah, we can check later that. Yeah. So this is the idea. Pair plot you can do same directly. You can call the pair plot. Nothing. And you remember hue based on the species we did already. And face it is again say one different types of just the grid. Yeah. Again, what type of plot you need on the grids, you only decided actually. Yeah. Same can do for a scatter plot. I leave this. Yeah, I think joint grid also is there. Okay, grids are actually giving you flexibility to what type of plot you need on axis and y axis actually. Yeah. So joint grid actually does is two of the column takes, right? Remember we talked joined plot was there. So grid is actually saying I am just defining these boxes. You decide how what to plot in these
It's
boxes.
like an empty draft.
Yeah, yeah, empty draft, and you want to plot regression plot. So inside this, well, regression plot, outside is the distribution plot. That's all. You decide it.
Okay.
So I think yeah, these are also little helpful when you want to do some different types. But yeah, remember there are default one. Those are also more than enough actually. Similarly, I think yeah, let's talk quickly on the regression plots. This is also same if you remember. We talked. Yeah, I think lmplot is quite useful, very generally used. So let's talk sns dot lm plot. Here actually it's a regression plot only. Linear. Why they call lm? I am forgot. So this you have to pass x and y value and the data, and on which regression line you want to fit or not, you have to true pass the true and false, or you want to do the plotting of logistic regression or not. Many types of inputs you can give. Let's try for the tips data actually. So we will say data is equals to tips, and x axis we will put total bill. axis is tips. So okay, I think tips is not there. Tip is there. Yeah. So here actually this one is very useful line where actually so when you see the slopes are like in the positive direction, this is positive, other way around it is negative, and if it is straight it is zero correlated. So this is when we say like tip is on the positive axis, you can directly say the bill increases, your tip will increase. And this plots you can actually do based on multiple, right? Only not on this, maybe you can do on what all the we have, dinner and all. Yeah, so I remember, don't remember, maybe. Yeah, so based on the, yeah, this category also sex was there. So you can see sex is lesser correlated, kind of based on the female has lesser correlation for the male in comparison to male, and you can actually do such plots based on different data set. This is one plots, lmPlots based on, yeah, u equals to sex. I also tried. Similarly, you can, yeah, I think these are just nothing, only passing one more argument, color, what type of color you want. And oh, okay. So in these plots, actually, you can pass this markers, how you want to define the points. Actually, you can say V is actually saying this triangles, and O is our circles. Actually, you can write like this markers. So I think, yeah, this one we wanted to do calls where you say different plot for different columns. When we say columns, then it will actually plot different diagram for different sex or different category actually. So you can see the female versions are little lower inclined towards tip and total bill, but male versions were actually, male data is actually higher in the correlation. So yeah, then actually you can do again on the what to say, row is also there and column is also there. Then based on time also you can define such correlation and change the color and play with the data set, which actually makes feel good, and you can conclude something. We just go with that actually. Similarly, you can, yeah, increase the size, decrease the size and all. These are also there. I think regression plots are very useful. Yeah. So generally you go at max, you will go like this. Yeah, this one where row and column you are mentioning. Yeah.
Okay,
Mhm.
Rishi, I'll just tell my general understanding what I got for this.
Yeah, correct. Sure.
Initially, we'll make one empty draft of graph. In that graph, we will define like what is the data needs to be passed and what is the type of graph we needed, and it is like next based on that, what is the correlation that we are trying to find, and then we are doing the color indications like to see what is the, I mean, based on colors, we are trying to find some patterns. And later on that, just now what we saw for labels, like male had a one design and female had one design. So finally, we'll see like based on that, this is the final analysis that we are able to get it. So for, I mean, yesterday to today, we did those things only, right?
Yeah, yesterday today we try to categorize the data, like different types of data will have different plots. Here you can see we are actually plotting for only numerical values, and they are actually in float values, not the integer ones. So this one is regression plots are generally for float numbers. And if you remember, the other plots were actually categorical plots also there. That is actually based on the groups and other thing. And yeah, regression plots you can actually categorize based on different things. We just did for size and the time actually, right? Sex and the time, yeah. Oh, we only have two time, lunch and dinner. Lunch and dinner. Yeah, correct. So, meaning you have Seaborn gives you facility to actually plot many things, but based on your data only, you try decide what type of plot I need to plot. And in that grid one model, there is format like you decide what type of plot you need. But by default, they are having some fixed data sets and fixed categories or fixed values. They will columns, they will select data, they will select and plot for you. And they are very much customizable. In case you do not want this total build versus tip, you can directly call this as size, then you will see the plot for size versus total build. Yeah, these are very customizable also. Yeah, that customization piece you can, yeah, forget also, no issue. Only thing is if you required you can change. Remember just now we were changing the size of the plot. Style is nothing. Yeah, so I think when you say set style, it's giving you the background as black, white actually. In this one, it was blue background. By default, it is blue background, I guess. Oh, oh, we are getting some white backgrounds. So these are the things. Do you need ticks or not? So you will set these style ticks. So you will get lot of ticks marks. Not lot of, based on the data itself. Female has one tick, male and the spine. I'm not sure. Yeah, what the spine removal. Oh,
That's it was there.
yeah, boxes removed, right? Yeah. And oh, only left side you should remove, not right side. Yeah, or not the bottom side. Size you just asked, right? So it is you can use matplotlib figure and fix size, width, and height to change the size of almost most of the Seaborn plot. And this you can control actually. So 2 by 3, see, 12 is the width and the 3 is the height. So how the plot changes. Hmm. See, this size is 2, then size is 2, aspect is 4 actually. Scale of the context also you can change, set the poster and font scale. Colors you we already talked. I'm not sure what they're talking about this puppy plot. So these are some plots. Will actually, yeah, after this class better you try this exercise, then you will revisit all the things. It will make you like comfortable more. Yeah. It's just I think yeah